Welcome, learners. My name is Mr. Pochilola once again. I hope your exams are going on well. So far, so good. We just finished week number 1 of your exams. And we look forward to a beautiful week next week. And it is next week when you are going to write your chemistry paper 1. For that reason, I decided to revise with you this paper. This is paper 1, chemistry paper 1 from Southeast Education Division, SEED. This is because we promised you that we are going to revise with you. We are going to be with you up to the end of the exams, revising and making more video lessons. Once again, if you are writing MSCE next year, 2027, or if you are in Form 3 this time, consider enrolling for lessons on Black Slides Online Secondary School. We make sure we cover all topics which are exam focused in order to boost your confidence. This is the place to have best preparations aimed at producing the best results. Welcome, learners. So once again, without wasting your precious time, consider subscribing if you have not done so already, and also hit the notification bell so that every time we upload a new video material, you become the first to know. Welcome, learners. So this is chemistry paper 1 from SEED, from Southeast Education Division. My name once again is Mr. Pochilola. Welcome to section A, which carries 70 marks. I'm sure we are supposed to have an instruction here. The standard manual paper is supposed to have an instruction here that says answer all questions in the spaces provided. Here, I think there's an omission there. Question number 1. Explain why bond breaking is endothermic and bond making is exothermic. In other words, we should explain why bond breaking requires an energy input, while bond making releases energy to the surroundings. Explain why. So bond breaking requires energy. So energy is required to overcome the attractive forces holding atoms together. So energy is absorbed, hence it is endothermic. So in order to break bonds in a chemical reaction, energy must be absorbed because there's need to break or to overcome the attractive forces that hold atoms together. So energy therefore must be absorbed. Therefore, bond breaking is endothermic, meaning that it requires an energy input. Bond making, on the other hand, the atoms move to a more stable lower energy state. For the atoms to move to a more stable lower energy state, energy must be released. Therefore, bond breaking is exothermic. state any two importance of endothermic reactions in everyday life. Remember that endothermic reactions are the reactions which absorb energy from the surroundings. So these kinds of reactions are important in everyday life. The common ones are photosynthesis. During photosynthesis, plants absorb energy from sunlight to convert carbon dioxide and water into glucose and oxygen. This is done in order to sustain life on Earth. So the most important part of the answer is that plants absorb energy, that's endothermic, from sunlight in order to convert carbon dioxide and water into glucose. By saying this is 1 mark. Another importance is seen in humans in a process called sweating or evaporation of sweat from your skin. So the body absorbs heat energy from the skin to turn sweat into vapor, which cools the body down. So that too is an endothermic process. Naturally, heat is needed for the skin to lose water through sweat. Remember that excess water must be removed from the body. So that's done by a process called sweating. So during sweating, the body absorbs heat energy from the skin to turn sweat into vapor, which cools the body down. That's also an importance of endothermic reaction. Another application or importance of endothermic reactions is seen in instant cold packs. In instant cold packs, chemicals inside react and absorb heat from the surroundings. This is done in order to reduce swelling and pain in the injuries. This too is application of an endothermic reaction or process. We see an importance of endothermic reaction or process in melting of ice. For ice to melt, it must absorb heat from its surroundings from the environment to turn into liquid water, which is used for cooling drinks, or preserving food. So heat energy must be absorbed. All these are importance of endothermic processes in everyday life. Take note that some of these are not necessarily chemical reactions. They're just processes. Define a polymer. We define a polymer as a large molecule which is made of many small repeating units called monomers. I've seen this question from another paper, I think. I can't just remember which paper it was, and we also made a video based on that. So these monomers are linked together by covalent bonds in a long chain. Once again, a polymer is a large molecule made up of many small repeating units, which are called monomers. And these monomers are linked together by covalent bonds in long chains. Defining monomer. Just 1 mark. Remember that definitions in sciences attract only 1 mark. So do your best never to miss a definition in an exam. Figure 1 shows polymerization process of one of the monomers. So we have these monomers. When you have a chlorine attached to an alkene, that's called vinyl chloride. These are vinyl chloride molecules, vinyl chlorides, also known as chloroethane, monochloroethane, sorry. Okay, but suffice to call them vinyl chlorides. So name the type of polymerization shown by the reaction above. Since these molecules are identical, then this reaction or polymerization must be addition polymerization. Unlike condensation polymerization, the molecules being added up are different. Okay, that's how you'd know. But also during condensation polymerization, a smaller molecule is produced apart from the main polymer. Name the polymer formed. So name this polymer. Since it's just an alkane chain, a long chain with chlorine atoms bonded to the parent chain, then this must be polyvinyl chloride. Polyvinyl chloride, in short known as PVC. So this polymer formed is called polyvinyl chloride, in short PVC. So this is PVC. You have many vinyl chlorides joined together, but you can also call this polychloroethene. Polychloroethene. Either of these two. Don't write both. Just write one which comes to your mind at that point. This is 1 mark. Describe how the polymer mentioned here above is formed, 2 marks. Alright, that means we must produce 2 points also. Remember, the number of marks indicated give you a clue as to how many points you need to give. So describe how the polymer mentioned above is formed, how PVC is formed. Right, so the double bond here, this one here, the double bond, the carbon-carbon double bond in the chloroethene has to be broken. So each of these bonds is broken and the monomers link together to form long chains with no small molecules being released. Alright, so by saying the carbon double bond in chloroethene is broken, that's 1 mark. And then monomers link together to form long chains, that's another mark. 2 marks altogether. So this part here which says no small molecules are formed, that may not be important. It doesn't add anything to the number of marks. Yeah, but the marks shall come from, say, the carbon-carbon double bond in chloroethene breaks, that's 1 mark. Monomers link together to form long chains, another mark. Or you can say long chains of PVC. Welcome, learners. Figure 2 shows allotropes of carbon labeled P and Q. So these are allotropes of P and Q. I've also seen this question quite a lot, and I think some of the videos we have made so far had a question like this of this one in one way or another. Remember that allotropes are different forms of the same element. So carbon, for example, can exist in 2 forms. It can exist as diamond, which is this structure here, and graphite, which is this structure here. Identify the allotrope that conducts electricity. So the allotrope that conducts electricity is this one here, which is Q and is graphite. So using the letters, you write Q there. Don't write the name. Okay, I've just put the name in brackets for you to be able to tell or to recall that this is graphite, but the answer is Q. 1 mark. Which allotrope is used to make surgery instruments? Okay, by the way, we are saying Q because graphite exists in layers of hexagonal shapes, okay, and also each carbon uh, in graphite is bonded to three others, leaving one electron free for conduction. So graphite conducts electricity. So graphite is Q. Which allotrope is used to make surgery instruments? Remember that diamond is such a very strong material and it also non-corrosive material. Therefore, it is the best choice for making surgery instruments. Surgery or instruments are those instruments that are used in carrying out medical operations or surgical operations in the hospital. So, which allotrope is used to make surgery instruments? Most definitely P. Don't write the name. If you want, you can just put in brackets. So P is diamond. One of the uses of diamond is to make surgical instruments. Explain why the allotrope mentioned in 3A2, this one is used to make surgical instruments. Why? Alright, so recall that diamond is extremely hard material and it has a very high melting point and is chemically unreactive or innate, so it does not corrode or react with body fluids. For that reason, it is the best choice of material for making surgery instruments or surgical instruments. Welcome learners. Just any one of the responses given here will give you 1 mark. Don't write all of them. After all the questions, just 1 mark. Explain why ionic compounds conduct electricity in a molten state and not in a solid state. Alright, ionic compounds do not conduct when they are in solid state, but in a molten state, when melted, or when they're dissolved in water, and then they can be used to conduct electricity as electrolytes. So 2 marks. The 2 marks here are coming from you saying that in the solid state, ions are held tightly in a fixed lattice and cannot move freely. So the ions in a solid state are not so free to move. Therefore, solid state cannot conduct electricity because the electrons, the ions, are not so free to move. They are tightly held together in a fixed structure which is called a lattice. So when molten, the ionic lattice breaks down, ions become free to move around and carry electric charge. Hence, ionic compounds conduct in a molten state. Welcome learners. State any one use of perspex. Perspex is a type of glass. There are different types of glass. There's perspex. There's also another type of glass which is called borosilicate. This particular one is the one that you see in the lab. The beakers, the test tubes, the measuring cylinders, especially those that are meant to be heated or to be used in heating experiments. They are called perspex glass. So perspex glass is used to make lightweight, shatter-resistant windows. It's used in car lights, display signs, spectacle lenses, beakers. You can put test tubes, as many materials you can remember. Just any one of these. define oxidation in terms of electron transfer. Oxidation is defined as the loss of electrons by a substance. So when a substance loses electrons in a chemical reaction, that's called oxidation. When a substance gains the lost electrons, that's called reduction. Know the different ways of defining oxidation and reduction. So oxidation can be defined in three ways. You can define oxidation as the loss of electrons by a substance. You can also define oxidation as an increase in the oxidation number, also known as oxidation state. You can also define oxidation as the gain of oxygen. Welcome, learners. The electrode potential of copper and iron are shown as given below. The very first one here is iron ions gaining electrons to form iron atoms. This is reduction. And the potential associated with such a change is minus 0.44 volts. Copper ions gaining 2 electrons reduced to copper atoms is accompanied by an electrode potential of positive 0.34 volts. So using this data, we are asked to find the EMF, the electromotive force, which is basically voltage of this cell obtained when copper and iron are combined. So when you combine these two, how much voltage will the cell generate? All right. So from the first one, we have iron being reduced to make or to form iron atoms. And this is more negative. So if we reverse this equation, half equation, by the way, these are called half equations. So if we reverse this, it means that the electrode potential associated with it is also going to reverse or change sign. So if this was initially negative, when we reverse this one here, we shall have a positive 0.44 volts. So if the forward process is a reduction process, then it means that the backward reverse process is going to be an oxidation. Remember, oxidation is an increase in the oxidation number. So this has 0 here. When go back, it's going to increase to 2 plus oxidation. So upon reversal, this must be positive. Alright, so if we keep the second equation, half equation, unchanged, you see that here we shall have copper ions gaining 2 electrons to form copper metal. And the electrode potential associated with it is 0.34 volts. So these are the two values that we are going to use in order to calculate the EMF of the cell of these two equations combined together. So the EMF of a cell is equal to the electrode at cathode. Remember, at cathode is where reduction happens, minus the electrode, the potential at the anode where oxidation takes place. Alright, so in this case we shall have 0.34 4 volts. This one here for reduction, and the minus 0.44 for the oxidation process. So simplifying this and adding, you get 0.78 volts. Welcome learners. State any one use of propanone. Remember, propanone is an alkanone. We make use of this a lot in everyday life chemistry practices. State any one use of propanone, which is an alkanone. This can be used to remove nail polish, especially the ladies. It can also be used as a solvent for paints. It can be used in varnishes and glues. It can be used to dissolve grease and oil. Of course, it goes back to solvent. It can also be used in the manufacture of plastics and synthetic fibers. Define the term alloy. An alloy is defined as a homogeneous mixture. Not just a mixture, but you have to say homogeneous mixture. A homogeneous mixture is one that shows a consistent mixture. It does not show separate layers of the mixtures, the components of the mixture. So it's a homogeneous mixture of a metal with other metals or non-metals to improve its properties. Welcome learners. So that's the definition of an alloy. Which alloy is used in the manufacture of airplane parts? Airplane parts are made by alloys which are called duralumin and aluminium alloy. Okay, duralumin and the aluminium alloy is made up of aluminium mixed with copper, magnesium, or manganese to form this type of alloys used for airplane parts. Take note of that. Figure 3 is a diagram showing chromatograph process of ink spots X and Y. Let's just look at the diagram together. So we have ink spots X and Y placed here on a paper, chromatograph paper, dipped in a solvent. So the solvent can be an alcohol or something else. X separates into M and P, while Y separates into N and R. The distance traveled by N is 4 centimeters, while the distance traveled by the solvent is 10 centimeters. Welcome learners. So these are called chromatograms. Just master the diagram very well. Let's look at the questions based on it. What two components are absorbed more strongly by the stationary phase? The stationary phase in this case is the paper, the chromatograph paper. I'll bring it right here. Which two components are absorbed more strongly? Alright, so in this case, we are saying the stationary phase is the paper itself, because the paper is not involved in the movement. The mobile phase is the alcohol and the pigments. So which two components are absorbed more strongly? So for you to tell which components are absorbed more strongly, just look at the components that have moved the shortest distance. So in this case, it's M and N. They have only moved 4 centimeters. Unlike P and R, P has moved much further than M and N, and R has moved the farthest of all. Right, so the answer is M and N. The shorter the distance they travel, the more they are absorbed by the paper. Right, so the explanation here is we are saying it's M and N because the components that travel the shorter distance are held more strongly by the stationary phase. Which component is most soluble in the solvent? The component that is most soluble is the one that has traveled a long distance, the longest distance. So in this case, R has traveled the longest distance of O from the starting point. That means it is most soluble. Most soluble. So in this case, it's R. We are saying it's R because it has traveled the longest distance compared to the others, to M, N, and P. So R traveled the farthest distance with the solvent, showing high solubility in the mobile phase. Calculate the relative flow value known as RF value for component M. For component M, in order for us to calculate relative flow value, remember that it's a ratio of the distance traveled by the component. In this case, M has traveled 4 centimeters divided by the distance traveled by the solvent. So in this case, first of all, looking at the marks means you have to lay out your work in 3 steps, 3 marks. Alright, so in this case, you first of all write down the formula. Relative flow value, RF, is given or calculated by distance covered by this component. In this case, the component is M, has traveled a distance of 4 centimeters divided by distance moved by solvent. So the distance moved by the solvent is 10 centimeters. The distance moved by the component is 4 centimeters. So all you have to do now is to substitute and calculate. So substituting the values, distance traveled by component is 4, distance traveled by solvent is 10. So 4 divided by 10, this should give us 0.4. Take note that the relative flow value of a substance does not have units because the centimeters cancel out by the end of the day. Welcome, learners. In case you have questions to ask us relating to our school, don't hesitate to send us a message to the number given here. Welcome, learners. Methane, which is an alkane, reacts completely with oxygen to produce carbon dioxide and water. Write a balanced chemical equation for the reaction, 2 marks. Usually the marks come from 2 steps. Writing the equation correctly with the correct formula, you have 1 mark. And balancing it, also another mark. That gives us 2 marks altogether. Welcome, learners. So in this case, make sure you write the substances correctly. Methane is CH4. Just transfer this one down here, and oxygen is O2. This is combustion. Alright. So combustion produces carbon dioxide and water. And then you balance accordingly. For carbon, we are safe. We have 1 carbon there. We have 1 carbon here. But for oxygen, we have we put a 2 over here. 2 times 2 is 2 plus this 2 oxygen. That's 4 oxygen atoms. But this side we need to multiply 2 by oxygen to give us 4 again. Just practice how to balance equations. Balancing equations shouldn't be a problem. It's something that you have learned from Form 1. If 3.2 grams of methane reacted with oxygen, how much carbon dioxide was produced? So here we are given the reacting quantities. 3.2 grams of methane reacted with oxygen. How much carbon dioxide was produced? Alright, so our basis shall be only molar masses given. So if you work out, let's work out the molar mass for methane. Since there's one carbon atom and four hydrogen atoms, so one carbon is 12 and one hydrogen is 1, so 4 multiplied by 1 is 4 plus 12, that's 16. That's the molar mass of methane. So using the molar masses and the given mass, we can find the number of moles of methane that are involved there in the reaction. So number of moles is equal to the given mass divided by the molar mass. In this case, we have 3.2 grams divided by 16. So 0.2 moles of methane react with oxygen there. Remember, we are asked to say how much carbon dioxide is produced. So the mole ratio of methane to carbon dioxide is 1 to 1. Where are we getting the one from? There's one here, one more, and there's also one more there. So the ratio of methane to carbon dioxide is 1 to 1. That means the number of moles of carbon dioxide that will be produced is also going to be equal to 0.2 moles, just like the number of moles in of methane, which is 0.2 moles. Welcome, learners. Alright, so molar mass of carbon dioxide is 44. Where from? Carbon is 12, 2 oxygen atoms is 2 times 16, which is 32. 32 plus 12, that's 44 grams per mole. Alright, so the mass, how much carbon dioxide? Therefore, the mass is going to be equal to the number of moles, which you worked out here, multiplied by the molar mass, which is going to be 8 grams. So 8.8, not 8, but 8.8 grams of carbon dioxide will be produced under those conditions. Welcome, learners. Calculate the volume of oxygen required to burn 3.2 grams of methane completely at the room temperature and pressure, given that the molar volume at this room temperature and pressure is going to be 22 cubic decimeters. One mole of any gas occupies this volume, 24 cubic decimeters. So we are asked to calculate the volume of oxygen that will be needed to burn the three. Remember, this is a continuation of the same question. To burn 3.2 grams of methane. How much oxygen is needed? Alright. So once again, we need to find the molar mass of methane, which we already said is 16 grams per mole. Alright. And the number of moles of methane is going to be molar mass, the given mass divided by molar mass, 3.2 divided by 16, which is 0.2 moles. Right, so the mole ratio once again, this time we are looking at methane and oxygen. I'll take you back to the previous slide. Here, the mole ratio of both methane and oxygen is 1 to 2. That means for us to find the number of moles involved in this reaction for oxygen, we shall take the number of moles that we found for methane multiplied by 2. Right, I hope we are together there. So the mole ratio is 1 to 2. That's the ratio of methane to oxygen from the balanced equation. Alright, so the moles of oxygen therefore will be 2 multiplied by the moles of methane, which is 0.04. So use the fact that 1 mole of a gas buys a volume of 24 cubic decimeters. What about 0.4 moles? Alright, so you simply multiply the number of moles by the molar volume. So in this case, multiplying 0.4 by 24 to give us a volume of 9.6 cubic decimeters. Define water pollution. We shall define water pollution as the introduction of harmful or toxic substances into water bodies. Water bodies here can mean lakes, dams, ponds, seas, oceans, rivers, making the water unfit for use. So the introduction of harmful or toxic substances into water bodies makes the water unfit for drinking, unfit for cooking, unfit for washing. State any two pollutants of water. Water is considered to be polluted if it contains any of the following things: industrial chemicals and heavy metals. Heavy metals are metals like lead, mercury, and others. If it contains raw sewage and human waste such as feces and urine, as well as blood, such water is considered to be polluted. Agricultural fertilizers and pesticides, oil and petroleum products, plastic wastes and solid rubbish, detergents and household chemicals. Any two of these is considered to be pollutants. Mention any two of the benefits of hard water. Remember that hard water is one that has very high concentration of dissolved salts of magnesium and calcium, like magnesium sulfate or calcium sulfate. Such water is said to be hard water. So it has high concentration of ions of magnesium and calcium. Alright, so such water is very, very important in a number of ways. The question is requiring us to say two. So provides calcium and magnesium ions needed for strong bones and teeth. If you drink such water, you'll benefit from it calcium and magnesium ions into your body, which will make your teeth and bones strong. It also reduces risk of heart disease. The ions such as calcium and magnesium are helpful to give the muscles in the heart the ability to contract and relax well. State any one advantage of reduction at source as a way of minimizing waste. Reduction at source means that reducing the amount of waste generated at a particular place. So reduction of waste has an advantage. Okay, and your examiners are looking for that. So reduction at the source reduces the cost of treating and disposing waste, while it is also at the same time preventing pollution before it occurs. That's one mark, reduces the cost of treating and disposing waste. Welcome, learners. In case you have questions, don't hesitate to send us a text message on WhatsApp regarding black slides. We are going to come back with a response very immediately. Number 8. What is meant by empirical formula of a compound? We shall define an empirical formula as the simplest whole number ratio of atoms of each element present in a compound. In other words, we are looking at the simplest formula of a compound based on the simplest whole number ratio of atoms of each element. Work out the empirical formula of a compound that has the following percentages by composition. Percentage composition by masses. Alright, so the compound has 40% carbon, 6.67 hydrogen, and 53.33 oxygen. And where each element is given its relative atomic mass. So you take these to be equal to grams, these numbers. So we have 40 grams, 6.67 grams for hydrogen, 40 grams for carbon, and 53.33 grams for oxygen. Alright, so you lay out your work in table form. This simplifies things. Okay, so the atoms present are carbon, hydrogen, and oxygen. And the percentage of each given here, carbon makes 40%, hydrogen makes 6.67%, and oxygen makes 53.33%. The relative atomic mass of carbon is 40. So we can use these two numbers, the mass. Remember that I said that these values are basically masses. If you add them up, they must give you 100 grams. So these are grams per 100. Alright, so to find the number of moles, you simply take the percentage, which is the mass, divided by 12, divided by ram. So 40 divided by 12 is 3.33 moles of carbon are present in the compound. The number of moles in the hydrogen will be the given mass, which is as good as the percent, divided by 1, it's 6.67. While the number of moles in the oxygen is going to be 53.33 divided by 60 is equal to 3.33. So these are moles. Alright, so in order to find the ratios in which the atoms are combined, you divide each of these numbers by the smallest number. So if you look at these numbers here, the smallest is 3.33. So divide 3.33 by 3.33, you get a 1. Divide 6.67 by 3.33, you get a 2. This goes into that two times. If it doesn't come out as whole number, make sure you round it off to get whole number. Remember, by definition, empirical formula is the simplest whole number. 3.33 divided by 3.33, that's going to be 1. So the ratio in which carbon, hydrogen, and oxygen combine to form a compound is going to be it's going to be 1, 2 to 1, 1 to 1, 1 to 2 to 1. Therefore, the empirical formula is going to be CH2O. So there's 1 carbon, 2 hydrogen, and 1 oxygen. Welcome, learners. Let me ask you to revise on this and also be able to write down the molecular formula of a compound when you're given enough information about its empirical formula. So this table plus the formula is 6 marks. Welcome, learners. State any two uses of phosphoric acid. Phosphoric acid finds its application in many places. It can be used in the manufacture of phosphate fertilizers like ammonium phosphate fertilizers. Phosphoric acid is one of the raw materials, but it can also be added to food and drinks as an acidulant. An acidulant is a substance that is deliberately added to food in order to enhance its flavor. Think of drinks like Coke, Fanta, and other soft drinks. The acidic taste that you get from them is due to some level of phosphoric acid added to it. So, two of these 2 marks. Below are condensed formulae of some organic compounds. Okay. Alright, so we are asked to name organic compounds and B. A is simply a compound called 3-methylpentane. Pentane 2,1. In other words, A is an arcanone. How do you tell an arcanone? An arcanone is identified by the carbonyl group. This part here is a carbonyl group CO. So both sides is within a structure, an alkane structure or alkyl structure. So when you have CO in the middle of two hydrocarbon chains, when you have a carbonyl group CO between two hydrocarbon chains or alkyl groups, then that's an arcanone. If it was an arcanal, the CO could be at the end, like here. This is an arcanal. On the other hand, alright, so you need to identify also the position of the double bond. The double bond is only the position of the, beg your pardon, the position of the carbonyl group is on carbon number 3. 1, 2, 3. Alright, so that's where we have this CO. So it be C3, C is 3-methylpentane 2,1. Alright, but you need to be careful here. A little bit careful. This is 1, 2. Yeah, this CO is basically attached to carbon number 2, counting from my left hand side. This is 1, 2. So it's there, this one, where this one is attached. That's the meaning of these two here. Alright, on the other hand, this one, when you have something put in brackets, it means it's a branch. So this branch occurs on carbon number 3. Yeah, it occurs on carbon number 3. Try to draw structure. This structure, you then need to come out clear to tell that where each one of them is located. In case you are not sure, please kindly send me a text message. I'll be glad to rectify what I have not clarified in the first place. So this is methyl 3. If you check 1, 2, the main chain is 1, 2, 3. Yeah. So that means the branch is only carbon number 3, which makes sense. And the functional group, the carbonyl group right here, is on carbon number 2, 1, 2. This one is attached to this carbon. Just to draw it out and confirm what I'm saying. B is a compound called 3-methyl pentanoic acid. So we have 1, 2, 3, 4, 5. The main chain has 5 carbon atoms. The branch is on carbon number 3 right here. That's why it's called 3-methyl pentanoic acid. The main chain has 1, 2, 3, 4, 5. It has to be pentanoic acid. Similarly here, if you take the methyl group, you have 1, 2, 3, 4, 5. So the methyl group is on carbon number 3. And the CO bond, which is the carbonyl group, lies on carbon number 1. Draw the structure formula of compound which has a conformer to organic compound C. So organic compound C, this looks like I said earlier on, this is an alkenyl. It will please you to know that this is butanol. How do we know that this is butanol? When the CHO is at the end, like this, and there's no hydrogen chain this side, it's just on one side. That's an alkenyl in the first place. Unlike here, the CHO is between two alkyl groups. This tells you that it's an alkanone. This is alkenyl. Alright, so we are asked to draw the structures, different structures of this. Remember, conformers have basically the same formula and also the same structure. They only differ on the orientation of the carbon atoms at some points due to rotation. Alright, so this, which is butanol, can be given by either this formula, where the carbonyl group is at the end, like here, but you can also have it like, you can twist this part, can come this end to produce this. Basically, this is the same molecule. The only difference is on the orientation of this last part here. It's like this has just been flipped this end to produce this. So these are conformational isomers. Welcome, learners. Which organic compound can react with compound B to produce ester? Remember that for an ester to be formed, an alkano and an alkanoic acid must react. So let's look at B. B is an acid. We are safe there. But which other one can react with B to produce an ester? Remember, an ester is also called an alkanoid. So already B is alkanoic acid. How do we know that? It has COOH. So we need a compound that has OH in it. Definitely it's D. It has an OH here. That means this is an alcohol. So a B, which is an acid, will react with a D, which is an alcohol, to form an ester. So which organic compound can react with compound D to produce an ester or alkanoid? So in this case, to be compound T, which compound which organic compound can give positive results with tolerance test. Remember that tolerance test has to do with formation of silver mirror in a test tube. When you add a tolerance reagent to a sample in a test tube, the contents of the test tube are going to change to mirror like color, silver mirror image, so rather silver mirror. Okay, so it will form silver mirror in the test tube to show that it's an acanal. So the compound that gives a positive test with silver with this tolerance reagent is an acanal. So we need to check which one it is. If you go back, an acanal here is C, the one that has cho at the end. That's how would you tell that this is an acanal. So the response to that is compound C. It's only an acanal that will give us a positive result of forming silver mirror with tolerance reagent. Write the products of the following chemical equation. We have ethanol. This is ethanol reacts with sodium. When ethanol reacts with sodium, by the way, sodium reacts with sodium in the same way as sodium and water. One of the products is hydrogen, but the other one, it will simply be a compound in which the hydrogen is replaced with sodium. So in this case, the product will be sodium ethanoate. This is sodium ethanoate. Sodium ethanoate is a displacement reaction. Sodium is going to displace hydrogen. So it will form this sodium ethanoate. It's the azote. Sodium ethanoate to also form hydrogen. Check that this equation is fully balanced. So the 3 marks are coming in for writing this correctly and this correctly and then balancing it. Check that the equation is balanced. You have 2 times 2 for carbon, you have 4. Here 2 times 2, 4. We are safe on carbon. On oxygen, we have 2 times 1, that's 2 oxygen atoms. Here 2 times 1 is 2 oxygen atoms. Hydrogen, here we have 6 times 2, that's 12. Here we have 2 times 5, that's 10 plus 2, 12. We are good. Welcome, learners. Welcome to section. This is the last question in section A. Figure 4 shows a graph of volume of gas collected against time for the reaction of magnesium with hydrochloric acid at a certain concentration. So figure 4, graph for the reaction of magnesium and hydrochloric acid against time, volume versus time. What was the maximum volume of the gas collected from the reaction? At the start, the volume was 0. But as the reaction is progressing until it stops, this flat part here represents the progress of the reaction when the reaction has stopped, has come to an end, probably because one of the reactants is finished. So all you have to do is draw a dotted line, go to the y-axis, the volume axis, right here. This will give you the maximum volume. So the maximum volume, if you check, this is roughly 25, or it can be 24 point something. I expect that students can either say 24 or 25 over here. After all, this grid, it's not a standard grid, but you can still estimate, take the difference between any two known values. This is 10. 10 divided by 4 is 2.2. So each division is 2.2. So you simply consider this is 0.2. Sorry, each division is 5 divided by 4. Okay, that's 5 divided by 4 is basically 1 point, something like 0.2. So 1.2, you take this times 3, that's going to be 3.6, something like it's close to 24. You can say 24 or 25. It's okay. After how many minutes did the reaction stop? So the reaction stopped somewhere here. The point when this graph is becoming flat, that's where the reaction stopped here. This portion here represents a situation where the reaction has come to an end. So this happened somewhere roughly at 10 minutes over here. Don't say here, because there's still reaction going on those very slowly. So it's 10 minutes. But I would also give mark if anyone says 9.5 or something like that, roughly, but not 8. 8 is too far. This is where the graph began to get flat. So it's 10 here. So the reaction stopped after 10 minutes. Calculate the rate of reaction between 1 and 3 minutes. Between 1 and 3 minutes. So 1 minute is basically somewhere here. 1 minute, 3 minutes is somewhere there. So what was the rate? Alright, so for us to find rate, remember rate is volume at 3 minutes, is volume at 3 minutes, volume here is roughly somewhere there. Volume at 3 minutes minus volume at 1 minute divided by time difference. So the time difference is the time between 1 minute and 3. That should be 3 minus 1, which gives us 2. So volume at 1 minute, at 1 minute, at 1 minute is, depends, it's somewhere 12 cubic centimeters. Well, these values are basically estimates because this graph is not to scale. I mean, well, the proper scale, but these grids have issues. Right, just estimate this could be 12. And volume at 33 minutes, 3 minutes. Okay, we can take 3 minutes to mean here, 1 minute, whatever the case. So 3 minutes will be somewhere there. The graph is not good enough. Alright, so in this case, the time difference is just 2 minus 1. 2 minus 1. The time here subtract the time there. That's 3 times minus 1, which is 2 minutes. And then, therefore, rate is going to be 30 minus 12, which is 8 divided by 2. That's 4 cubic centimeters per minute. Explain how burning of fuels causes global warming. Remember, global warming is an average change in temperature of the Earth. It's caused by a number of factors. One of them is burning of fuels. Alright, so burning fuels basically releases, this is 2 marks, releases carbon dioxide gas and other greenhouse gases. That's by saying that you have 1 mark. So these gases trap heat in the atmosphere, leading to global warming. By saying these 2 points, you have 2 marks there. Welcome, learners. Describe how deforestation, which is the cutting down of trees without replacing them, increases the concentration of carbon dioxide in the atmosphere. 5 marks means 5 points must be raised there. So trees and plants absorb carbon dioxide, that's what we know, from the air during photosynthesis. That's 1 mark. So when forests are cut down, fewer trees are left to take carbon dioxide in, so less of this gas is removed from the atmosphere. If the cut trees are burned, they will release carbon dioxide back into the atmosphere. So it's like, in the first place, we cut trees, the amount of carbon dioxide decreases, the amount of carbon dioxide to be removed by the plants decreases, and if the trees that we have cut are burned, the carbon dioxide is going to be added back to the air. Right, so even if trees are left to rot, decomposers, bacteria and others would break down their wood and release the stored carbon as carbon dioxide through respiration. These are very strong points. Make sure you understand what's going on here. So the double effect, in this case, that of respiration and burning, reduced absorption leads to reduced absorption and the extra release of carbon dioxide, the concentration increases in the atmosphere. 5 marks, 5 points. Describe how nitrogen is isolated from air in the atmosphere in the laboratory. So the first thing that needs to be done is to remove carbon dioxide from it. Remember that air contains 78% nitrogen, 20 or 21% oxygen, and 0.034 carbon dioxide. So in order to get pure nitrogen, you must remove carbon dioxide and the other gases. So carbon dioxide is removed first by passing it through sodium hydroxide solution. So in the process, there is also sodium hydroxide, which is reacted with carbon dioxide in order to remove it from the air. So moisture is also eliminated when the air is then passed through concentrated sulfuric acid. Remember, sulfuric acid is a drying agent, so it will remove moisture from the air. And oxygen is reacted away when the dry mixture is passed over heated copper tannings. Remember that oxygen is an oxidizing agent on its own. Alright, so it will react with copper. Sorry. it is going to pass through copper to form copper oxide. In so doing, oxygen is removed. So the solid copper oxide is formed as oxygen is removed from the mixture. At the end, pure nitrogen is collected as the only major and reactive gas left. That's how we will separate nitrogen from the mixture in the lab. With the aid of a well-labeled diagram, describe how copper can be refined using electrolysis process. When a question requires you to use a diagram, make sure the diagram is fully labeled. By drawing the diagram before you label it, you have 1 mark. And by labeling at least 3 parts, you have another mark. So the diagram will give you 2 marks altogether. Whatever you say down here, it must refer directly to the diagram. So fill an electrolytic cell with copper sulfate solution. If what you want is copper metal, then the solution must be copper sulfate. We say that the ions, the atoms in the metal must be the same as those in the solution. So here we must have copper ions in the solution. If the metal desired is going to be copper metal. So take note. So we have anode, that part which is connected to positive end of the battery, and then the cathode, the electrode that's connected at the negative end. Remember also that it is at the anode where oxidation happens, and it is at the cathode where reduction happens. Take note. Much as this is not a conventional symbol for a battery. I beg your pardon there. So fill an electrolytic cell with copper sulfate solution. Once that's done, connect the impure copper to the positive terminal of the DC power supply to act as the anode. So it is this one which needs to be purified. It's an impure copper metal with some impurities. Alright, so connect a film sheet of pure copper. Okay, we start with a pure sheet of copper metal. We like the copper atoms to be deposited here. So connect a thin sheet of pure copper to the negative terminal. It's over here. Please make sure you draw the correct version of the battery there to act as the cathode. Switch on the power supply to allow electric current to pass through the electrolyte. So close the switch here. So the current will be flowing through the circuit. Then copper atoms from the impure anode will dissolve into the solution as copper ions. This is oxidation. So copper atoms are becoming copper ions into the solution. So the copper ions move through the electrolyte, and upon getting here, they will gain electrons, and copper metal, which is pure, is deposited there. So insoluble impurities fall to the bottom of the cell as anode mud, while soluble impurities remain in the solution. So you continue doing this until the cathode gains a thick layer of pure refined copper and the anode becomes smaller and smaller. So the pure metal copper is going to get into the solution in form of copper ions, which will gain electrons upon reaching there to form more copper, pure copper metal. Welcome learners. So check 3 marks there for the setup, and then for the description you should also have about 7 marks. If this is 4, then yeah. So here we are assuming that the diagram without labels is 1, and with at least 3 labels it must be 2. Welcome learners. My name is Mr. Pochilola. Then reach me on the number shared here. Welcome to the last question. In a laboratory, labels fell off from the bottles containing an alkane, alkene, alkano, and alkanoic acid. Describe an experiment that could be done to identify the contents of the bottle. So it's not known which bottle is which one. So you are describing an experiment to tell which bottle contains what. Welcome learners. So first of all, label the 4 known liquids as A, B, C, and D, and place the samples in separate test tubes. So together you have 4 samples that are labeled A, B, C, and D. So add a few drops of bromine water. Remember, bromine water is brownish. To samples A and B and shake gently. Alright. So the sample that decolorizes bromine water, the one that removes color, brown color to colorless, must be an alkene. Remember that alkenes contain a double bond, and when added to bromine water, the brown bromine water will change color from being brown to colorless. The sample that does not decolorize must be an alkane. Alkanes, due to their saturation, remember that alkanes are saturated hydrocarbons, and when you add the bromine water to them, to alkanes, the color of the bromine does not go. It persists. Then prepare a pink sodium hydroxide solution by adding a few drops of the northern indicator to sodium hydroxide solution. Remember that this gives us a pink solution. Then add equal volumes of samples C and D separately to the pink solution of sodium hydroxide solution. You observe the color change of the mixture in each of the test tubes. So the sample that turns the pink solution colorless is the alkanoic acid, because it neutralizes the sodium hydroxide in it. The sample that does not change the pink color is the alkano, in this case, assuming that both of them are identifiable using this approach. Hence, all the 4 bottles now are identified as alkane, alkene, alkano, and alkanoic acid. So make sure you write 10 points in order to get all the 10 marks. Welcome learners. So this has been your teacher, Mr. Pochilola, having taken you through the entire paper. Let me urge you not to just memorize these things. course, we don't guarantee that these are the questions that you're going to face, but we want just to remind you the standard answers as required. Welcome, learners. Expecting to see you soon. Bye bye.